Hello everyone. So today we will see problem based on bulb. Okay. So many students find difficulty in solving these problems. So I thought I should make a separate lecture. So these formula of power we have seen. Power equals to energy by time. Power equals to voltage into current. Power equals to current square into R. Power equals to voltage square by R. Basic formula we have seen. Okay. Now in case of bulb, you will always find these terms. There will be these terms given, that power rating and rated voltage of a bulb. So these kind of statement will be written that a 400 watt bulb is there that is rated at 110 volt. What does that mean? That means that if you give 110 volt, if you give 110 volt to the bulb, it will consume 400 watt power. Okay. So if you give 110 volt to the bulb, it will consume 400 watt power. That means it will give you the light according to 400 watt. There is a bulb in your room that is lit, right? That is giving you some light. So if it has a rating of 110 volt and a power rating of 400 watt, that means if you are giving 110 volt to it, it will give you a power equivalent to 400 watt. What if you give it 95 volt? So it will give you the power equivalent to whatever the power you get. So it will give you the power equivalent to 95 volt. What if your voltage was 90 volt? So it will give you the power equivalent to 90 volt. Okay. And what if it was 120 volt? So it would give you the power equivalent to 120 volt. But there is a chance that in this case it may fuse. Okay. There is a chance that it may burn out at this condition. So if it is rated at 1110 volt, you are advised to give 1110 volt only, maximum 1110 volt only. Okay, there are some special kind of bulb that can take plus 10% as well. That means you can give 1110 plus 10% of this 11. That means 1 to 1 volt as well. But it is advised to give 1110 volt across it. So at 1110 you will get the maximum light. After that also you may get light, but there is a chance that it may burn out. Okay. And if you are giving less, that means the bulb will give less light. That means the intensity will be low. If you are giving 1110 volt, that will be the best intensity. But here at 95 volt, here 90 volt, that intensity will be low. Okay. Got this point? Now there is this I rated. So mostly these two terms are power rating and voltage rating. These two terms are given. But what if they sometimes they can give I rated as well? So what is I rated? So I rated is simply power rating upon V rated. That means what is power rating? That is 400 watt and it was this. Okay. So it would be some 400 watt by 10. That means if in the bulb this much current is flowing, that means it will give you the power equivalent to 400 watt. If in the bulb 400 by 1110 ampere current is flowing, that means it will give you the power equivalent to 400 watt. And if the voltage across the bulb is 1110 volt, that means it will give you the power equivalent to 400 watt. Got my point? Now very important point, very important point, that is the resistance of the bulb. Resistance of the bulb. So this is always fixed. Okay, just remember it. Resistance of the bulb is always fixed considering constant temperature. We are not seeing the effect of temperature here. Okay, with respect to temperature it may change, but considering temperature constant here. Okay, so we are not seeing the effect of temperature here. We are just seeing the effect of these voltage rating or power rating or current rating. Resistance of the bulb will always be constant. You have to remember it. So what will be the resistance? That will be, okay, what is power? Power is V square by R, right? Power is V square by R. So R would be V square by P. So what would be R? That would be V rated square by P, or what you can say, power is I square into R. So R would be P by I rated square. It would be P by I rated square. So always remember it is fixed. So what is this P? P is this power rating, P rating. It is fixed and it depends on the rated voltage, rated current and rated power. Okay. So if you are given the rated voltage, if you are given the rated current, you can find the resistance of the bulb, and that is fixed. That doesn't depend on the supply. The resistance of the bulb doesn't depend on the supply. Okay, I am writing this point, very important point, and this is the most confusing point to everyone. The resistance of the bulb does not depend on the supply. Depend on the supply. Okay, it doesn't depend on the supply. Okay, it is V rated square by P rating. So in this case, what will be the resistance? The resistance would have been 1110 whole square by 400, right? The resistance would have been 1110 whole square by 400 ohm, right? V square by P. That's it. We will solve the questions now. It will be more clear to you. Now, what is being shown in the question? That a 150 watt bulb is there that is rated at 1110 volt. Calculate the value of Vs if the light bulb is operating at its rated condition. The light bulb is operating at its rated condition. That means it is working at 1110 volt. It is working at 1110 volt. That means this same voltage will be given to this. Okay, that means how much current is flowing here? 1.1 ampere, right? 1110 by 100, 1.1 ampere, right? And if you know the power, if you know the voltage, what will be the current? Current will be P by V, right? Power by V. So here the current would be 15 by 11. 15 by 11 ampere. So what will be the current here? The addition of both of them. So I need to bring the calculator. Let me bring the calculator. Basically from here 2.46 current is coming. Did you understand how did I write 2.46? 15 by 11 plus 1.1. Look, it is working as a rated condition. So 1110 will be same will be going here. That means 1.1 ampere current is there. Now I know the voltage, I know the power. That means there is 15 by 11 ampere current is flowing through the bulb. So 15 by 11 ampere current is flowing through the bulb and 1.1 ampere current is flowing through this resistor. Now the addition of both of the current is going into 50 ohm. So 15 by 11 plus 1.1, that would be 2.46, and 2.46 into 50. That means here I am having 123.18. Okay, instead of that I should write here. Here I am having 123.18 volt. Okay, so my Vs would be 123.18 plus 1110. That means 233.18 volt. This will be my Vs. This is going to be my Vs. Did you understand? The voltage, the bulb was working as at its rated condition. Rated condition was 1110 volt. That means the same voltage coming here. The current I know, this current I know, this current I know. I know the voltage drop here. This is the voltage drop plus this voltage drop is equals to Vs. That's it. Okay. Let's move on to the next problem. So this is a very good problem. Okay. Two questions are there. 3 bulbs each rated at 1110 volt. This is rated. It is not saying that it is working at that condition. The bulbs are rated at 1110 volt. Okay. It's not necessary that this is getting 1110 volt. It's not necessary that it is getting 1110 volt. It can get something else as well. Okay. So they are rated at 1110 volt and now connected as shown. Find the power delivered by the 220 volt source. So that means you just need to find the current from this. If you need to find the current from this, that means you need the resistance here. And if you need the resistance, you have to replace the bulb by its equivalent resistance. And the resistance of the bulb is fixed. It doesn't depend on this supply. So I can replace my 40 watt resistance, 40 watt bulb, I can replace my 100 watt bulb, and I can replace my 60 watt bulb with their equivalent resistance. And what is the value of resistance? So resistance for 40 watt bulb, what will be the value? V square by P, right? P is equals to V square by R, so it will be V square by P, right? So V rated square by P. What is my V rated? That is 1110 whole square by P. What is my P? That is 40 watt. So it would be 302.5. Similarly, my resistance for 100 watt. So it would be 1110 whole square by 100, right? Voltage square by 100. So it would be 1 to 1 ohm, I guess. 1 to 1 ohm, right? 11 की square 121 20, हाँ. Okay. So what will be the resistance for 60 watt? Voltage rating 1110 upon power. So this resistance has nothing to do with this supply. Got my point? This resistance has nothing to do with this supply. This resistance is fixed, and the value of this resistance is 1110 whole square by 60. 201.66 ohm. So basically now your circuit is something like this. This is your 220 volt. Okay, this resistance is 302.5 ohm. This is 121 ohm, and this is 201.66 ohm. Okay, now what did they ask? Find the power delivered by that 220 volt source. So I just need to find the current. What will be the current? So 121 parallel with 216.66. So I just need to solve it. So let me solve it. So from here I get the value of current. This is the equivalent resistance and this is the value of current. So what will be the power? Power delivered by the source. That would be 220 volt into 0.58. So into 220. So it would be 128 watt. The power delivered by the source is 128 watt. Okay. Now see one thing in this question. Okay. So now this is 0.58 ampere current. The same current is flowing here, right? 0.58 ampere current. This 0.58 ampere current is flowing here, right? Now through this resistance, how much current is flowing? 0.58 ampere current. So now you can calculate the drop across this resistance. So I am calculating the voltage across 40 watt resistance. Okay, so what will be the voltage across 40 watt resistance? That would be 302.5 into 0.58 ampere. So that would be 175.45 watt. Okay, so sorry. This is voltage. This is voltage. Okay. So now the voltage across this 40 watt resistance, this 40 watt bulb you are getting is 175.45. What was the rated condition? This was the rated condition. Rated condition was 1110 volt. So there is this high chance that this bulb may burn out because rated was 1110 volt. Now you are giving it 175.45 volt. So there is a very high chance that this bulb may burn out. Are you getting my point? I have the current, I have the resistance. From there I calculated how much voltage drop is there across the bulb. In bulb based problem, what you need to do? You know one thing, that resistance is fixed. Whatever is there, if I know P rated, if I know V rated, I can find the resistance. Resistance is fixed. I replace the complete circuit with the resistance only. Then I found out the current. I got the current 0.58 ampere in this resistance. Then I found out the voltage. So actual voltage is there 175.45, but it needs only 1110 volt only. 1110 volt only. So there is high chance that it may burn out. Okay. And what about these two? What about these two? So what is the voltage drop across them? 220 minus 175.45, right? 220 minus 220 minus 175.45. The voltage across both of them is 44.55, but rated was 1110 volt. Now these two bulbs will not burn out. These two bulbs will not burn out, but they will give very dim light, because rated we needed, that was 1110. We needed 1110, but we are having only 44.455. So are you getting the concept of bulb now? I hope everything is clear now. What is the concept? The concept says that my R is fixed. If I am taking a bulb from market, he will give me power rating and voltage rating. Okay, V rated he is giving and power rating he is giving. And the resistance is fixed of the bulb. No matter how much supply I give, the resistance is fixed. Now, based on the supply, I can find out my current. Based on the supply, I can find out my current. From there, I can get to know whatever the voltage the bulb is having. So, bulb was having this much voltage and these two bulbs were having this much of voltage. So, this may burn out and this will give you very dim light. Okay. So, this was the total concept. To solve the problem, this was the method, but I wanted to learn the concept here. Wanted to teach you the concept, not to learn. Okay. Now the question B is that all three bulbs are connected in parallel to 220 volt supply. Now you have to find the power delivered by the battery. Solve it on your own, then see the solution. Okay. All three are connected in parallel, so 40, 60, 100. Okay. Let's make the diagram. So part 2 we are doing. And what is the supply? Supply is 220 volt. Okay, you need to find the power delivered by the voltage source. That means you need to find the current from it. Then voltage into current will be your power. Now tell me, what will be the resistance of 40 watt? Will it be 220 watt square V square by P? Is this the correct answer? No, because it doesn't depend on the supply. The resistance of 40 watt is fixed. That will depend on its rated voltage and rated power. So what was its rated voltage? That was 1110 whole square by 40. So what is the answer we got here? 302.5. Okay, and the resistance of 60 watt is also fixed. That is 1 to 1. Oh, sorry. It was for 100 and this was for 201.66. 201.66. Resistance for 100 watt is 121 ohm. Okay, so these are fixed. Now these three are connected in parallel to each other, so you just need to find the current. What will be these three are connected in parallel. Okay, so I will calculate it and find out the value of current. So by solving this, we get the equivalent resistance equals 60.49 ohm and the current is 6.63 ampere. So what will be the power? Power will be voltage into current. Power delivered is 800 watt. Now tell me, in this case what will happen? All the three bulb has strong chance that they may burn out, because all the three bulbs are getting 200 volt, 220 volt. All the three bulbs are getting 220 volt. These three are getting 220 volt. And they only need 110 volt. If you are giving so much supply to them, they have the chance to burn out. And if they are very good, they can take up this much supply, then they will give you much brighter light. Okay. In the previous case, what did we see? Only 40 watt was having more voltage. These two are having less voltage. Okay. So they would give you dim light and this has chances to burn out. Right. But in this case, if you are connected in parallel, all of them have chances to burn out, and if they are very good bulb, then they can give you very brighter light. Okay. Let's move on to the next problem. Okay, so this was the important concept here, that even if the voltage across the bulb is fixed, still the R resistance will not change. R resistance is a fixed quantity. Resistance of the bulb is a fixed quantity that is depending on V rated square upon P rated. P rating, you should say, not P rated, P rating you should say. V rated square upon P rating. Okay. So many times students get confused with this point, that what voltage I should take. Voltage you should take only the rated one. Well and good. Let's move on to the next question. So this question was asked in some government exam, okay, or in some written test this was asked, and this was the question given. This bracket one was not written. Okay, this bracket one was not written. So this was the question given, that two bulbs are rated respectively P1 and P2 for operation at a specified mains voltage are connected in series across the mains. Okay, the total power supplied by the mains to the two bulbs are, okay, but they are not telling what is the V rated of the bulb. Although if you read this statement, what they are saying, operation at a specified mains voltage they want to say, specified mains voltage are connected in series across the mains. That means this mains only is the rated voltage of both of them. So P1 is having rated voltage of V and P2 is having rated voltage of V. So sometimes it may not be written. So you have to understand that whatever the mains that you have applied, that is the rating voltage of bulb P1 and bulb P2. Okay. So in this case as well, this is the voltage rating of bulb P1 and this is the voltage rating of bulb P2. So that means bulb P1 and P2 are having voltage rating of V volt. Okay. Now what is the thing? The thing is that we will solve the first problem now. You have to find the total power supplied by the mains. That means again you need to find the current, and if you need to find the current, then what will happen? You need to find the resistances, right? So let's take the first problem. This is the bulb P1, this is the bulb P2. You have the supply V, P1, P2. Okay, this has the voltage rating of V. So tell me, what will be the resistance of P1? That would be V square by P1. Now you will not say that here I will not have V volt. You can say that here I will not have V volt. Okay, you will not have V volt. That's fine. But what is the resistance? Resistance is a fixed quantity. Resistance is a fixed quantity. It doesn't depend on the voltage that you are having. Like in the previous case, in this case, what was the voltage I was having here? The voltage was 175.45 volt. But my resistance was not depending on this voltage. This resistance was not depending on this voltage. Right? This resistance, 40 watt resistance, doesn't depend on the voltage that I am finally having. It is depending on V rated and P rating. That's it. So here my resistance is fixed. That doesn't depend how much voltage I am having here. It doesn't depend on this. Okay. So this is fixed, and that would be V square by P1. What about resistance across? Resistance for P2, that would be V square by P2, because both have V rated equals to V volt. In this line you can see specified mains voltage are connected in series across the mains. So this is the rated voltage of this is the rated voltage of this. So here you find out this resistance is, so now you can replace the circuit something like this. There are two resistances, V volt, this is resistance is V square by P1, here the resistance is V square by P2. Okay, and what is the current? This is the current that you need to calculate. So what will be the current? Current will be V by V square by P1 plus V square by P2. What will be the power? Power will be V into I. So it would be V square upon V square by P1 plus V square by P2. If you solve this, what is the power you get? P1 P2 upon P1 plus P2. Okay, so this is the power delivered by the mains. Are you getting my point? Now what is the voltage across this resistance? The voltage across this resistance. What is the voltage across this resistance? That would be V square by P1 upon V square by P1 plus V square by P2 into V. What did I do? I applied voltage division. Resistance upon total resistance into voltage V. So this is the voltage I am having across this bulb P1. Across bulb P1, I am having this much of resistance. Sorry, this much of voltage. And this voltage is surely lesser than the rated voltage. That means it will give you dim light. This voltage is lesser than the rated voltage, right? This voltage is lesser than the rated voltage because total voltage is V here. So how can you expect more voltage than V? You would surely expect lesser voltage than V, right? जब V अप्लाई कर रहे हैं तो P1 के क्रॉस V से ज्यादा कैसे आएगा? P2 के क्रॉस V से ज्यादा कैसे आएगा? कम ही आएगा उनसे, सही है? तो आपके पास कम वोल्टेज है. You are having lesser voltage across P1 and P2. Then it will give, that means it will give you dim light. Okay, and now let's solve the problem B. In B, what was the case? Both are connected in parallel. So I would request you guys to solve this problem on your own. And this is voltage V. So what will be the resistance for P1? That would be V square by P1. And what will be the resistance for P2? That would be V square by P2. Is it depending on this voltage? This resistance is depending on this voltage? No. This resistance is depending on the rated voltage of this. What was the rated voltage? That was V. And now P1 and P2 are getting the rated supply only. What was the rated supply for P1? That was V volt. What was the rated supply for P2? That was V volt. What in this circuit, what they are getting? P1 is getting V volt only, P2 is getting V volt only. So they will lit at the certain power. That means they will give you a certain power of P1 watt. And this will also give you a power of P2 watt. Okay. So this will give you a power of P1 watt, this will give you a power of P2 watt. If both are connected in parallel and they are given the same supply as the rated supply, both bulbs are given the same supply as the rated supply, so that means they will lit at the given power only, that means at the rated power only. The rated power is P1 and P2. Did you get this statement? Did you understand this statement? Both P1 and P2 are given the rated supply only. What was their rated supply? That was V volt. So they are given the rated supply, so they will lit means they will light up at the rated power only. What was the rated power? Rated power was P1. So they will light up at the P1 power only, and P2 will also light up at the P2 power only. So this will consume P1 power and this will consume P2 power. So what will be the total power? That would be P1 plus P2. But let's just solve it by the concept that we have studied. Okay. So this bulb can be replaced with this resistance. That would be V square by P1. And this bulb can be replaced with this resistance. That would be V square by P2, and here I am having V volt. What will be my current? That would be V by V square P1 parallel with V square P2, right? What will be my power? That would be V square upon V square common may come out 1 upon P1 parallel with 1 upon P2. So I hope you can solve this. If you solve this 1 upon P1 parallel with P2, you will get P1 plus P2. You can solve this, right? 1 upon P1 parallel with 1 upon P2. What will be the answer? 1 upon P1 into 1 upon P2 upon 1 upon P1 plus 1 upon P2. So it would be 1 by P1 plus P2, and there is 1 upon 1 upon, so 1 upon P1 plus P2, so P1 plus P2 will be the final answer. Okay, this is my final answer. So that's it. These kind of problems are asked. Okay, so what you need to do, always if they are asking the power supplied by the voltage source, 99% chance is there that they will ask the power supply by the voltage source or by the mains. Okay, so what you need to do, you just need to find the current, and for finding the current you will replace the bulb with its equivalent resistance. The important point to note here is that the resistance of the bulb depends on the V rated and P rated, not on the supply. That's it. This is the complete concept. Okay, so these are some good questions. Now I will give you one assignment problem. You will find the solution of this problem in the notes, but I want you to comment down the answer. So when you get the notes in my Telegram group, you will see the solution in the notes only. Okay, but I want you to comment down the answer. If this was the case, then what would be the sorry. If this was the case, P1, P2, P3, and supply is V. So if this was the case, tell me what would be the power supplied by the mains. This P1 is having voltage rating of V. This P2 is having voltage rating of V. P3 is also having voltage rating of V. All are having voltage rating of V. So tell me what will be the power supplied by the voltage source or the mains, you can say. Okay, all are having voltage, each bulb is rated at voltage V. Okay, what will be the power supplied by the voltage source? That you need to tell me. You need to comment down the answer and try to think it more intuitive. Okay, don't do much calculation, just try to think what will happen. I will give you an hint. This is my supply voltage and this is my rated voltage as well. So P3 is having the same voltage. P3 is having the voltage equals to rated voltage only. So how much power it will give? P3 power it will give. What about P1 and P2? Here we have solved it. So do your calculation, whatever you do, I need you to write down the final answer. Okay, so I will give the solution in the Telegram group only, in the notes only, but you have to write down the final answer in the comment section. Okay, so let's meet in the next video with assignments. Okay, thank you. Okay, so let's see this question. Okay, that's a very interesting question, and many of the times students get confused. Okay, so I will deal 3 circuits here. So in all the circuit you need to find the value of V1, V2 and I. First circuit is this. Second circuit is the same, but there is ground mentioned. Third circuit is the same, but there is ground mentioned at both of the side. What changes it will bring, that we will see. Okay, there is one simple thing I told you already. Whatever the current battery gives, it takes back the same amount of current battery gives, it takes back the same amount of current. Of current. Okay, so let's just assume this battery is giving you I1 current. That means it will take back the same amount of current I1. That means this I1 current is flowing here. If it is taking back the same amount of current I1, that means this I1 current has to flow here as well, right? So in the complete loop, I1 current is flowing. What did you see? I1 current is flowing here, so it is taking back the same amount of current I1. but there is no other path mentioned, right? There is no other path. This I1 current has to flow this 1 ohm resistance and also through this 1 ohm resistance because of this I1. So this complete current is flowing in this loop only. So if this complete current is flowing in this loop, there should be no current going that way, right? Similarly with this, let's just assume it is giving you I2 current. So that means it will take back the same amount of current I2. That means it will also take the same amount of current. So the same amount of current is flowing in the complete circuit. So the complete I2 current is flowing in this loop and complete I1 current is flowing in this loop. That means there is no current in this 0.5 ohm resistance. So the value of I is 0 ampere. Can you determine the value of V1 and V2? Is there any ground mentioned? We can assume any ground. Okay, we can assume any ground anywhere. If I assume ground here, what will be the potential of V1? The potential of V1 would be 3 volt, and the same potential will be same. The potential will be same, so you will say potential of V1 equals to V2 equals to 3 volt. Now, if I assume ground here, what will be the potential of V2? That will be 2 volt, right? Now you will say potential of V1 and V2 is equal because current is 0, so there is no voltage drop across this 0.5 ohm resistance. So potential of V1 and V2 is equal. So you will say the V1 equals to V2 will be equals to 2 volt. As per this, it will be 2 volt. If I assume the ground here, it will be 3 volt. No ground is mentioned. I can't really tell the potential of this point. I will assume the potential of this point is VA and potential of this point is VB. So if I write the nodal analysis, what I will write? V1 minus 6 by 1 plus V1 minus VA by 1. V1 and V2 are equal, right? V1 equals to V2. So I can write V1 minus VB by 2 plus V1 minus 4 by 2 equals to 0. Here VA and VB are not known. Are not known. That means, what does that mean? Here VA and VB are not known. That means V1 and V2 cannot be determined. Cannot be determined. Are you getting this point? This potential of these 2 points you don't really know. So here V1 and V2 cannot be determined. Okay, but the current will be 0 because this I1 current will be flowing in the complete loop. This I2 current is flowing in the complete loop. Did you see the concept? What did I say? Whatever the current battery gives, it has to take back the same amount of current. Okay, many of the times I have seen teachers saying that the complete current will be flowing in the loop. Complete current will be flowing in the loop. This is not the concept. The current that is given by the battery, the same current will be getting into the battery. Okay, same with this 4 volt battery. Now let's move on to the next question. Let's just see here. Now I am saying this is giving me I1 current. So this I1 current has no path, so I1 current will be flowing like this. Okay, now it will have to take back the same amount of current. So this is taking I1 current. It is again taking the I1 current. Now can you say by this analogy that I1 current will be flowing here? Can you say that? No. Why so? Because this I1 current has two paths. One path is this and one path is this. So this I1 is the addition of these two currents. So you can't really say that your I1 current is flowing like this. Okay. But let's move on to this part. You can say that if this is giving I2 current, that means I2 current is flowing like this. It will take back the same amount of current. Now this I2 current doesn't have any path, so it has to flow like this. So in the complete loop, I2 current is flowing. So here you can see that in complete loop I2 current is flowing. That means there is no current going this way, right? So again here the value of I is 0 ampere. And since this I1 current is going like this and there is no current going here, that means this I1 current is flowing here. Are you getting this point? What did I say here? If you go by this analogy that I1 current is given here and it is taking back the same I1 current, then you can't really say that this I1 current is flowing here. You can't really say that. What did you do? You went to this loop. You just saw that if this is giving I2 current, this will take back I2 current. So in the complete loop, I2 current is flowing. You just saw that. So what did you understand by that? Like if the complete current I2 is flowing, that means there is no current going this way. So that means in 0.5 ohm resistance, there is no current flowing. And if this I1 current is flowing in this 1 ohm resistance and there is no current coming from this, there is no current coming from this 0.5 ohm resistance, that means this I1 current should be flowing like this only. So this I1 current should be flowing in the complete loop. If I1 current is going out from there, then that means it has to flow like this, because there is no current coming from this side. So I1 current is coming, 0 ampere current is coming, so I1 current only will flow. So only by seeing this loop, you can't really say that I1 current will flow. When you saw this loop, then you could comment that I1 current will flow. Did you understand this point? Many of the times I have seen students and teachers saying that, okay, one loop, complete current will flow, complete current will flow, that's it. But that is wrong. This is not the concept. Because this complete I2 current is flowing in this loop, that's why there will be no current in this 0.5 ohm resistance. And because of that, this I1 current will flow in the loop only, because it doesn't have any other path. Are you getting this point? So in this question, what is the current going into the ground? That is 0 ampere. Because you got to know that I1 current is flowing here, I1 current is flowing here, so 0 ampere current is going in that part. Okay. Now tell me what will be the value of V1 here. Value of V1 would be, because this ground is mentioned here, now the value of V1 would be 6 by 2, that means 3 volt. Simply voltage division, nothing else. Right? Or you can say that the value of I1, or I can say, what I can say is, the value of I1 is 6 by 2, that means 3 ampere. So value of V1 would be 3 into 1, that means equals to 3 volt. That will be same as V2. Also here also, the value of I1 is equals to 3 ampere and value of I2 is equals to 1 ampere. And both of the current are flowing in the loop only, 3 ampere and 1 ampere. Okay. Here you can say value of I1 is 3 ampere and value of I2 is 4 by 4, that means 1 ampere. Right? What did I write here? 1 ampere and 3 ampere. The same amount of current, just the voltage drop now you can determine. Here you can determine the voltage V1 and V2. So V1 and V2 is equals to 3 volt here. Okay. What is the potential of this point? Let's just call it VB. Tell me what is the potential of this point? Because of 1 ampere current, there is voltage drop of 2 volt here. So if this is 3 plus 2 minus 4. This potential is 3, right? This potential is 3. 3 plus 2, 5. 5 minus 4, 1. So your VB is equals to 3 plus 2 minus 4 is equals to 1 volt. Okay, so this is not ground. This is 1 volt. This is 0 volt. This is 1 volt. Okay. Understood this concept? Let's move on to the next question. Again, try solving it on your own and tell me if the value of I is 0 or not. Let's just assume I1 current is flowing like this. It will take back the same amount of current. Here we can say that I1 current is flowing. Can you say the same amount of current is flowing here? By this loop, you can't really say. You don't really know the value. Now let's just assume I2 current is flowing here. So in this loop, I2 current will be flowing. We can say that. Now can you say now this will take back the same amount of current. Now can you say what is the value of this current? No. By this loop as well, you can't say the value of this current. I2 current is flowing like this. This will also take I2 current, but it has a ground. It will also have some current. It has a ground. In this question, it didn't have any ground. So the complete current was flowing in this loop. So you could tell that there will be zero current in this resistance, in 0.5 ohm resistance. But here you can see that this is not a complete loop. There is a ground as well, because both of these nodes are equal. So whatever the current is going here, the same current will be going into this. So addition of this current plus this current will be equals to I1 now. So ground will also have some current. Okay. Ground doesn't have zero current. Ground takes the current. Okay. So here you can't really say that this I2 current will be flowing that way. So here you can't really say. So here you will need to apply the nodal analysis. So applying nodal at V1. So V1 by 1 plus V1 minus 6 by 1 plus V1 minus V2 by 0.5 is equals to 0. Or you can write 4V1 minus 6 minus 2V2 is equals to 0. This is equation 1. Now applying nodal at V2. So it would be V2 by 2 plus V2 minus 4 by 2 plus V2 minus V1 by 0.5 is equals to 0. So it will be V2 plus 1 by 2. So it would be 3V2 minus 2V1 is equals to 2, or minus 2 is equals to 0. Right? I'm just solving the equation, nothing else. So V2, 2V2, 3V2 minus 2V1 minus 2 equals to 0. So this is the equation 2. So we will just solve the equation and get to the final answer. Okay. So what I can write, 6V2 minus 4V1 minus 4 is equals to 0. So just add them up. Adding equation 1 and 3, what do you get? 4V2 minus 6 minus 4 minus 10 is equals to 0. So V2 value we get is 10 by 4, that is 2.5 volt. Okay. And V1 value we will get is 2.5 into 2, 11 by 4. 11 by 4. What is 11 by 4? What is 11 by 4? Let me solve it with the calculator. 2.75. V1 value we get is 2.75. Let me recheck if the calculation is correct. Yeah, so the calculation is correct only. V1 value we are getting is 2.75. V1 value we are getting is 2.75 volt, and V2 value we are getting is 2.5 volt. Okay, so your I will be 2.75 minus 2.5 by 0.5. It will be 0.25 by 0.5. That means it will be 0.5 ampere. Right? Okay. So here your current is not equal to 0 but 0.5 ampere. Why it is happening? Because there is a ground at both. This potential was 2.75 volt and this potential was 2.5 volt. That means it is having 2.75 ampere current and this side is having 3.25 ampere current, and the rest of the current is going that way, that is 0.5 ampere current. And what about this? This is having 1.25 ampere current and this will have 1.5, this is 1.5 by 2. 1.5 by 2 matlab means 0.75 ampere current. Okay, so how much current this ground is having? 1.25 and 0.75 is going that way. That means this ground is having 0.5 ampere current. And from here as well you can see 3.25 and 2.75. That means this ground is having, okay, that means this ground will give 0.5 ampere current. So basically this 0.5 ampere current is coming and getting into it. Are you getting this point? Did you get the complete analysis? Did you understand the complete analysis? I will revise it once again. First we understood that your I1 is not equals to I2 here. That thing we understood. Okay. Then we saw that, sorry, here what did we understand? That here your I is not equals to 0 because I1 current is getting out, I1 current is getting in. So that means ground can have some current. Here your ground can drive some current. And in the same way, here also your ground can drive some current. So what we did, we applied the nodal analysis. In the previous question, we can't really apply the nodal analysis. If we apply the nodal analysis, what will we write? V1 minus 6 by 1 plus V1 minus 0 by 1 plus V1 minus V2 by 0.5 ohm. That is fine. But if you, can you apply the nodal analysis at V2? V2 minus V1 by 0.5. What is the potential of this point? Potential of this point is VB plus 4. Do you know the value of VB? No, you don't know the value of VB. Because ground is not mentioned. Here, even the potential is not mentioned. So you don't really know the value of VB. Okay. So you can't really apply that analysis. that V2 minus 4. You can't really write V2 minus 4 by 2. Okay, you can't really apply the nodal. But here you know the potential. If this is 0, this is 4. That's for sure. So you can apply the nodal analysis here. And you can also see that this loop is not having I1 current only. Okay, this complete loop is not having I1 current. When you solve the complete circuit, you got to know the value of V1 and V2. And here you can see 3.25 ampere current is going that way, 0.5 is going that way, 2.75 is going that way. And to the ground, 3.25 is going that way, 2.75 is coming from here. That means ground will drive 0.5 ampere current. So from ground, we are having 0.5 ampere current, and the same current is coming from the other ground. So this 0.5 ampere current is coming like this complete 0.5 ampere current. Are you getting this point? So here 0.75, 0.5, that means 1.25 current is here. So 1.25 current is here, 0.75 current is here, that means 0.5 ampere current is going downward. 0.5 ampere, 0.75 ampere. So 1.25 ampere current is coming like this. So this is the complete analysis. This is the value of V1, V2, I1 and I2 and everything. Okay. So what did we get as the value of I2? I2 value is 0.75 ampere. I2 value is 0.75 ampere. I1 value is 3.25 ampere. 3.25 ampere. The current in ground is 0.5 ampere. Okay, so I hope you have understood the complete concept. There are these three kind of questions are there. One, when there is no ground. Okay, when there is no ground mentioned, that means the current through the middle one will be 0. When there is one ground mentioned, the current through the middle one is again 0. When there are two ground mentioned, that means there can be the current between that two nodes. Okay, so there can be some current when there are two ground mentioned. So if two grounds are mentioned, then there can be the current. Okay, so I hope you have understood the concept. If they ask you any kind of question like this, you will be able to answer. Okay then. So okay, let's move on to the next video. Thank you. So let's see the solution of this one. So this is the best question of this complete test series. Okay, and I can say 0% guys would be able to solve it. Not even 0.1%. 0% I am saying. Even if I had been the aspirant, I would not be able to solve it. Okay. So yeah. So this is a uniform wire and represents a regular 5-pointed star. Regular 5-pointed star. So in a regular 5-pointed star, what is the scene? These side, this side, this side, this side, all are equal. What is your resistance? Resistance is proportional to length by A. Wire is the same, so A is the same only. Now all will depend on length. Everything comes down to length. Everything comes down to length now. Okay, so all these are equal. That means KD, DK, KD, DL, all these are equal. So I am not going to write all the lines, but you can see KD, DL, LE, FE, all these are equal, and so on. It will keep on going. CH and CK. But what about these length? KL. What will be the length of KL? Because you know the resistance of EL. EL is 2 ohm. So all these resistance you also know, right? If you know the resistance of EL, that means this will be 2 ohm, this will be 2 ohm, 2 ohm, 2 ohm, 2 ohm, 2 ohm. All these are 2 ohm. But what about these resistance? What about these resistance? What about these resistance? What will be the resistance of these 5? KL, HK, KL, HK, LF, GF and HG. What about the resistance of these? So here the concept of geometry will be used. Your good amount of geometry will be used. So let me take a triangle here. Okay, this is your E, this is your F, and this is your L. EFL. This angle is 36 degree. You can derive it from geometry. This angle is 36 degree. This angle is generally 36 degree. Okay, 36, not 30. This angle is generally 36 degree. So let's make it on the next page again. So this angle is 30 degree, 36 degree, 36 degree, FLE, EFL. And this is one of the favorite question of gate aptitude. They many times ask this angle. This is 36 degree. Okay, people usually remember for a regular star this angle is 36 degree, and in gate also it has been asked 2 to 3 times. In aptitude, not in certainly electronics, but in aptitude it has been asked. Now, and if I draw a perpendicular here, this will bisect. This will be 18 degree. This length I know. This length is L. EF length. EF length is L. This length I know. I need to find this length. I need to find FL. If I can find FL, this will be a regular pentagon. So FL all are equal. HK, KL, FL, GH, HG all are equal. This will be a regular pentagon. Okay, this is from the geometry. This complete structure is regular. Equal, equal. These are isoscalar triangle. Isoscalar. Okay, and angles are, this is 36 degree. Rest you can find, right? And this will be a regular pentagon. These will be 108 degree angle. So from there you can derive it as well. If this is 108, this angle you can derive. What that would be? 72. 72 plus 72, 144. This angle will be 36 degree. So with this derivation you can do. One thing you just need to know, all will be regular. So HA is equals to KL is equals to FL is equals to GH is equals to GF. Right? So this angle will be 80 degree. This will be bisecting. This will be bisecting this. Okay. So what will be my FL? FL will be 2 times of FO. My target is to find FO. How I can find FO? FO will be what? I need to find FO. So how do I find FO? Sine 18 degree is equals to FO by L. Say yes or no. So FO will be equals to L into sine 18. So if you find sine 18, what you will get? Let's check that. So it is roughly 1 by 3. Sine 18 is roughly 1 by 3. So it will be L by 3. So what will be your FL? FL is 2FO. FL is 2FO. FL is 2FO. That means it will be 2L by 3. Then if the resistance for EF, if the resistance was R, then for this one what will be the resistance? 2R by 3. Say yes or no. For EF the resistance was R, then for this the resistance is 2R by 3. So for these, what did we get to know? For these the resistance is 2R by 3. For these the resistance was R, for these resistance was 2R by 3. So KL 2R by 3. This also 2R by 3. So these are 2R by 3. Now what you need to find? You need to find the resistance between F and C. F and C. So let's check that out. F and C. This is your C and this is your F. So between C and H there is R. Right? Between C and H there is R. Between H and G, how much resistance is there? Between H and G. So let's check H and G. H and G. So H and G. H and G there is 2R by 3. Right? This is 2R by 3. And in parallel to, these two will come in series. BH and BG will come in series. What that would be? R and R, 2R. This is your H. This is your G. 2R by 3 parallel with 2R. 2R into 2R by 3 upon 8R by 3. So what that would be? R by 2. Okay. So 2R parallel with 2R by 3 would be R by 2. So this would be R by 2. So this resistance would be R by 2. Same goes for this one as well. This resistance will also be R by 2. Now what about K? So between C and K there is R resistance. Between K and L there is R by 2. And here also it is. Between F and L there will be R by 2. And between H and K, there is what? There is resistance 2R by 3. What do you need to find? You need to find the resistance between C and F. C and F. What about this resistance 2R by 3? This is Weisstone bridge. Look here. 2R and 2R in coming series. R. This is Weisstone bridge. This will be nullified. Right? This will be open circuited. This is of no use. Weisstone bridge is there. This is of no use. Then between C and F. Between C and F, what do you see? R parallel R, R by 2. Then this is R by 2, this is R by 2. In series it will become R only. R parallel R, R by 2. So between C and F, what do you get? Between C and F, you are getting R. So answer will be 2 ohm. That's it. So the motive behind this problem was just to tell you the thing that whenever, like, any kind of question can come in front of you in the examination, but you need to make sure that if they have given the resistance of a particular length, then you need to check the length as well. Okay, don't blindly say that, like most of the people would have solved it in this manner, that all will be of resistance R. But no, only EL was mentioned. EL was 2 ohm. This is 2 ohm, this will be equal to 2 ohm, but this will be different. This will be 2R by 3. So that was the main motive behind taking this question, that you should take care of the length as well. They can somewhere in some question, or let's just say in 2026 or 2027 or 2025, they can ask you the problem where they may ask you the question on geometry as well. So here the geometry was used. You had to find 2L by 3. So this was the concept. Okay, so this was a very good question.